Hi everybody. This week we are going to look at the two fathers of constructivist theory as we know it, Jean Piaget and Lev Vygotsky. And the screencast for this week will be in two parts, and this first part is about Jean Piaget. He lived from 1896 to 1980. He started his work as a biologist. He actually studied mollusks, like clams and mussels and things like that. But while he was working as a doctoral student, he was hired by Binet, who developed the first IQ tests, to score some of the research that Binet was doing, asking children questions. And the way that Binet developed the first IQ test, although he did not ever call it an IQ test, that was done by the folks at Stanford later, but the way he developed this first test was by asking lots of children of different ages general knowledge types of questions, like what do you write with, or how do you know which part of a book is right side up, or what is one important room in the house where you cook, things like that. And he kept careful track of how many questions children of different ages got correct. And that was how he decided what your mental age was. If you got the same number of questions right that, say, for example, a 9-year-old got right, then your mental age was 9. So that's how he was developing these tests at the behest of the French government. And so he hired a young Piaget to help him with this, and Piaget became interested not in how many questions people of different ages got right, but rather in the unique sorts of wrong answers that children of different ages gave. And so he began his independent work studying his own 3 children, and later established the Geneva Clinic with Barbel Inhelder, who is pictured down here at the bottom. And together they developed the research and psychology method known as the clinical interview, where children are asked a set of standardized questions, and their responses are used, in Piaget's case, to discover more about their cognitive development. So Barbara Enhelder was a close collaborator. She doesn't get the credit that Piaget got, and that isn't unusual to happen, but her name should be actually just as important. Anyway, Piaget's view of children and learners were as little scientists, people who were constantly trying by trial and error to figure out their world. He's called the father of constructivism because he was one of the first to assert that children, and in fact people in general, construct their own understanding and knowledge of the world through experiencing new things, reflecting on these experiences, and especially trying to make what they experience in the world match the constructions of knowledge they have in their own heads. This is one of my favorite quotes from Piaget. He says, "The principal goal of education is to create men, and of course women, who are capable of doing new things, not simply of repeating what other generations have done. Men who are creative, inventive, and discoverers." So his whole idea of learning stands in great contrast to that of the behaviorists. From the behaviorist point of view, you learn as a response to stimuli in the environment, and the response is not of your own choosing. You respond to reward, you respond to punishment, and learning is just these automatic responses. Even very complex learning is really a collection of automatic responses. And B.F. Skinner was the main proponent of this view, and he wrote a book called Beyond Freedom and Dignity, where he says basically we think we make decisions, we think we make choices, but it's really all just conditioning. And of course, interestingly, in writing the book, of course, he's asserting that his idea that it's really all just conditioning is not merely a result of conditioning, but in some way true. So I find that position a little self-contradictory. I'm much more of a constructivist, even though I do find worth in behaviorist theory. And I'm going to put together, there is a third large theory about cognition and learning called information processing. It's a very powerful theory right now. We did not have time to get to it today, but it's uniquely relevant actually to our field because it models human thought and learning on the computer. So I'm going to put together an optional unit and PowerPoint for those of you who are particularly interested in that in the next week or so. But anyway, right now, on with Piaget and constructivism. So Piaget's idea about how people learn goes as follows. Basically, when people construct a mental model of the world in their heads, how does the world work, what's in it, all those kinds of things. And as long as your experiences in the world correspond with that mental model, you are in a state of equilibrium. Remember, Piaget started as a biologist, so his whole idea of thought carries a great deal of the notion of biological adaptation in it. The idea that we try to adapt our mental models of the world to the experiences we have in the world. And as long as the world confirms our mental models, we have no disequilibrium, therefore we do not change or learn. But when the world does not confirm our mental models, when we have an experience that challenges our mental model, then we get into disequilibrium, which moves us to try to resolve this disequilibrium. And we can resolve this disequilibrium three ways. The chapter that you will read about Piaget will only discuss two of these ways, but there is a third way that we have researched and seen that many people use. Okay? So the first way to resolve this disequilibrium is to assimilate the new experience, the knowledge from the new experience, into our previous schemes, to just add on a little bit to the scheme. This is, for example, well, let's keep going. Let's say that you have a scheme for bird, okay? And you know about robins, and you know about pigeons, and stuff like that, okay? All of a sudden you see an ostrich, which is very different, and somebody says, that's a bird. Well, you're now in disequilibrium. The ostrich does not match what you think of as birds, which are fairly small and they can fly, which ostriches can't, and they aren't. So one way to resolve that disequilibrium is to assimilate the idea of ostrich into your previous scheme of bird. You just suck it in and say, okay, this is another bird, even if it's a little different. Okay, another way to resolve your disequilibrium is to accommodate or change your model, your scheme of knowledge. And the word scheme is what Piaget kind of used, although he is translated, so it's hard to tell. It may be just what his translators used. We often today use the word schema, which will crop up again when you look at information processing theory, if you decide to do so. A scheme or a schema is a mental construction, a mental model of how the world works. Okay, anyway, so to resolve this equilibrium, you can also accommodate or change your scheme to fit the new knowledge. And your final choice is to simply reject the new knowledge. This often happens when people's disequilibrium is too great. When disequilibrium that's minor is kind of a good feeling. We like learning. We like that sense of curiosity. But disequilibrium that is major feels very threatening because we also like to believe that on the whole, our mental model of the world is pretty solid, is pretty good representation. Because if it's not, it's very scary. If you no longer have a handle on what the world is really like, it can feel very threatening. So I want to give you two different examples, one that's very minor but very common, and one that's a little more serious and larger. Okay. One example is the child, remember, a very young child who is building their scheme or schema for dog. Okay, so the child has a dog in his home, and the dog, say, is a German Shepherd. Okay, and the child says, doggy, doggy. And then the child goes to another home, maybe a cousin or a grandmother or something, and there's a small poodle at the home. And his mama says, "Oh, here's Grandma's doggy. Say hi to Grandma's doggy." And the child looks at the little poodle and thinks about his mental model of doggy, which is modeled on his German Shepherd, and says, these don't go together very well. The child is in minor disequilibrium. Okay? But after everybody keeps saying it's a doggy, and after he notices that the poodle's sounds, they both bark, and it acts very similarly to his larger German Shepherd, he will assimilate the poodle into his scheme of dogs. Okay? So the poodle's now part of the doggy scheme. But something else happens very commonly to little children, and that is they're driving or walking along and they see a cow, for example, or a horse, and they point at it and say, "Look, doggy, big doggy." And mom says, "No, honey, that's not a doggy, that's a horse." Well, once again, we have disequilibrium because so far in the child's world, all four-footed, furry kinds of things are dogs, right? But now this isn't a dog, it's a horse. How do you resolve that? Well, at first, the child has tried to assimilate horse into the dog schema. The child has said, "No, no, big doggy." And mom says, "Nope, nope, not a dog, a horse." Okay, so assimilation didn't work. The child accommodates, starts a new schema, so to speak, and says, "Okay, not all four-footed furry things are dogs, so I have to change my dog model here. It doesn't include all four-footed furry things, and I kind of have to get started on another scheme. So, one for horse, which I don't know much about yet, but it's not going to be part of my dog scheme." So that's kind of an example of assimilation and accommodation. Now, let's talk about something a little more serious. Prejudices are often the result of the third choice in the face of disequilibrium. Perhaps a person is raised, as many people were in the South many years ago, to believe that people of a certain different race or ethnicity are inferior, are not industrious, are not smart, whatever. So they're raised with this scheme, this mental model of the world. And what happens is, of course, is that they will meet someone from that race or ethnicity that contradicts that scheme, who maybe is very industrious, very ambitious, very smart, very forthcoming, and they are in disequilibrium. They're in serious disequilibrium. Okay? Well, they could assimilate this knowledge into their previous schemes. They could say, "Okay, this person is part of this race or ethnicity, but they're a little different." Well, that's not going to work, is it? They can't assimilate, can they? So the choice we would hope they would make is to change their prejudices and accommodate or change their schemes and say, "I was wrong. This scheme about this minority or ethnicity is incorrect because look, I have evidence here that this is a person from that ethnic group and they're not like that." Okay? Unfortunately, because that's often a very central, powerful scheme, people will often reject the new knowledge. Instead of accommodating their scheme, instead of changing their beliefs, they will reject the new knowledge. They will say things like, "Well, most people of this ethnicity are lazy or not too smart or whatever, and this guy's just an exception. He probably had a really different experience. Maybe he's even like half white." They'll reject it. They'll say, "Well, they're mostly like this. This guy's an exception. He's not like that." Or they may try to believe that the person they're seeing in fact fits their stereotype and say, "Well, he may be looking smart, but really underneath, this is just something he's learned to parrot." Or, "Yeah, he may be putting on a good show of being ambitious and diligent, but we all know folks like him are lazy." So you can see how prejudice is the result of early schemes, but continued prejudice is the result of rejecting new knowledge that doesn't fit your schemes. Okay? So anyway, that's Piaget's theory of learning, that you have a particular mental model of the world. When the experiences of the world contradict your mental model, you go into disequilibrium, which forces you to either take that new experience into an existing scheme, change your scheme, or possibly simply reject the new knowledge and hold on to your own scheme, old scheme. Okay, here's another really good example of assimilation or accommodation in babies. Okay, one of the earliest schemes that babies develop is banging. The model that if you hit things on things, they make a really pleasant noise, a cool noise. Babies do this all the time on their table or their high chair with their rattle. Okay, well, baby finds a block. Okay, a block does not look like a rattle, so there's a little bit of disequilibrium here. But pretty soon, baby starts banging the block, and sure enough, the block makes a cool noise too, so he assimilates the block into his banging scheme. However, some poor person gave this baby an egg, and the baby tries to bang the egg. Guess what? It doesn't work. You can't bang eggs. So now the baby is forced to accommodate or change the scheme. And previously, the baby thought you take anything in your hand, you hit it, and it bangs. Well, some things don't do that, do they? So that's a change in the scheme, that there are some things which bang, but other things which are not successfully banging. Okay? That's a comic but very true example of the difference between assimilation and accommodation. Okay? Now, besides his learning theory, the other parts of Piaget's theory that is extremely well known, if not better known than his learning theory, are his 4 stages of cognitive development. So we're going to talk about them very briefly. The first stage, which is approximately, and all of these ages are very approximately age 0 to 2, is an extremely important stage. It is what Piaget called the sensory motor stage, because the vast majority of learning that occurs in that stage comes from actually touching and feeling and sucking on and moving things. In other words, in the sensory motor stage, children, babies, have to be able to directly touch things to learn from them. You can't teach 0 to 2-year-olds things by telling them about them very easily. Okay, there's a lot of really important things that happen in this stage, including language development. But one of the very first things cognitively that happens in this stage is something called object permanence. And object permanence is when babies first begin to construct those mental models in their head of things in the world. So this happens around the age of 6 to 8 months. And before maybe 5, 6 months old, babies do not have in their heads, it doesn't seem, consistent mental models of things. So, for example, one of the first things that babies construct a model of is their caretaker, often their mother, but whoever's taking care of them. Now, before the age of 5 or 6 months, you can take a baby to a social gathering, a party, or maybe a church service, and you can hand the baby to other people who hold it, and the baby will look at them and smile just like he or she smiles at you, because they don't have a mental model yet in their head of, oh, does this person look like mom? They don't have anybody to compare it to. Okay, so you hand them from person to person, and as long as they're fed and they're dry, they're smiling, they're happy. All of a sudden, between the age of 6 and 8 months, you take a baby maybe to a family gathering, you hand the baby to grandma, baby takes one look at grandma and starts to scream blue murder. Go, and you think, oh my goodness, what's wrong? Nothing's wrong. This is a good thing, believe it or not. Because what's happened is now the baby has in his head a mental picture or model of mom. And he takes one look at grandma and says, that's not mom. Oh my God, I'm with a stranger. I've been abandoned. And they scream. Okay? So that development where the slightly older baby is not happy being left without mom, is not happy being left with somebody else, is actually good cognitive development because it shows the beginning of object permanence. Those of you who've studied psychology realize that object permanence is necessary for attachment, which is the foundation of all relationships that we build, the attachment of a baby to their main caregiver. And you have to be able to recognize your caregiver before you can be attached. But object permanence is also the foundation of something else that's desperately important, and that is language. You can't have a word for something until you have a mental model in your head of what the thing is. You have the mental model, you attach the word to that mental model, and that's how we learn language. You can't learn language until you have mental models, objects in your head, stored away in your head. So at this time, if you want to, I would suggest stopping the screencast here and watching the video of Lucille. Lucille is 6 months old. She was the daughter of one of my teaching assistants, and this video gives the best example of what happens when you don't have object permanence, and then later when she develops it. She's younger than 6 months at the beginning, and she's over 6 months at the end. And if you didn't believe in object permanence after you watch this video, you will. Okay? So take pause right now and then go ahead and watch that video. Okay, so now you've seen a key piece of development in the sensory motor stage. We're going to look at the pre-operational stage for a minute here. Pre-operational kids have mental models of things in their heads. They have mental models of mom and the bears and the toys and all kinds of things in the world. It's amazing what they develop. So they can talk, they have words for things, but they can't operate on those models in their heads yet. They can't rearrange those models in their heads. They can't say, well, what if I did this? They can't do that yet. And that's why Piaget calls them pre-operational. So they can represent the world symbolically. They have the symbols in their head. They're capable of pretending that a block is a car. They have good language. They can do a lot of things, but there's a few things that they can't do. And I want to take a look here. Okay, a pre-operational child, if you line up a bunch of buttons or pennies or something, 2 rows of them, and you stretch one row out, even if you take away a penny and you say which is bigger, they will say that the row that's been stretched out is bigger, because they're not capable of operating on that image in their head and saying, oh, even though they spread them apart, there's not more there. The classic one is the third one down here, and you're going to watch somebody do that with Roxanne. You can take 2 glasses that are exactly even in water, and the child will agree they're even. You can pour 1 glass into a different sized dish or taller glass and say, which one has more? And the child will say, they're different now, because the child cannot do conservation yet. The child cannot mentally operate on their image of the model in their head and say, okay, even though the water looks different, I can tell it couldn't be different because no water left. There was no change. We didn't take away any water or add any water. They can't do that. Another thing they have a lot of trouble with is putting things in sequence. They also have difficulty with classification. And a thing that's really fun about kids this age, and we're back here at pre-operational again, is they think magically. They don't realize yet that their thoughts do not necessarily impact reality. So the child at this age is what we think of as a terrible liar, because to them thought and intention are just as solid as the real world. So the child who runs in from the backyard and says, Daddy, Daddy, there's a dragon in the backyard, and he's really convinced there is because they thought about a dragon. They thought how interesting it would be. They imagined it, and they're not really sure yet about the line between imagination and reality. Likewise, the child who maybe is bouncing a ball in the living room, and mom says, don't bounce that ball, you're going to break the lamp. And mom leaves, and the child starts bouncing the ball again, and pretty soon, sure enough, the ball breaks the lamp, right? And mom comes back in and says, why did you do that? Why did you break the lamp? The child will say, I didn't break the lamp. I really didn't. Because in their mind, what they're saying is, I did not intend to break the lamp. I did not act so as to break the lamp. Now, truly, the fact they were bouncing the ball resulted in the lamp breaking, but you see, they don't have cause and effect down real well. So what they're saying is, I didn't break the lamp, it was the ball. It wasn't I didn't do it. I didn't mean it to happen. So this is what we call the age of magical thinking, and it's kind of interesting as long as you realize what's going on. And right now, I'd like you to stop and take a look at Roxanne, who is Lucille's older sister. Roxanne is a very bright little 4-year-old, but watch how she cannot conserve. She cannot disregard appearances and mentally in her head say, well, I know the appearance was transformed, but the thing remains the same. She can't do that. So it's really interesting to watch. So take a second and watch that. Okay, I don't have videos for the next two, unfortunately, but let me tell you about concrete operations. That's the next stage. This is the stage most kids are in throughout elementary and into middle school. Okay, concrete operational thinkers do have mental images, models in their head. But like the pre-operational thinkers, but now they can operate upon them. They can reverse them. They can imagine what would happen if you turned it upside down, or if you spread it out, or you pushed it together. So they can operate on things. But Piaget calls them concrete operational because they usually can only operate on models of things they have seen or touched. Things that were at least concrete. They don't have to stay that way, but they have to start with the concrete. They learn best if they start with things they can actually manipulate, see, and touch. And then they're able to construct the models in their head and then operate upon them. They're not good at abstracts. A kid this age, if you ask them, well, what would happen if nobody could talk? What would it be like if nobody could talk in the world? Is very likely to tell you, well, but people can talk, but okay, you get over it and you say, but what would happen if nobody could talk? And a kid this age is likely to say, well, everybody would just have to write down what they want to say, not realizing that if people couldn't talk, language would never have developed. They're not good at hypothetical situations. A classic experiment to do with kids this age is to say, if you had a third eye, if you could have a third eye, where would you want it? And a kid this age will very likely tell you, but people don't have 3 eyes. They're very concrete, okay? And even if you get past that and you say, yeah, I know that, but if you could have a third eye, where would you want it? A concrete operational kid will say, well, on my forehead, right here between my other 2 eyes. Why? Because that's where eyes are. Whereas an older kid moving into formal operations will think of things like, well, I think I'd like an eye on the tip of my finger because I could use it to look over tall things or around corners, you know, or I'd like an eye on the back of my head so no one could ever sneak up on me and I could see in all directions. It would be better to drive, you know. They are able to think of hypotheticals. They're also, when you get to formal operations, you can think of abstract things that have no concreteness, like justice, or mercy, or, for that matter, algebra. Okay, so why do these things matter? Well, because kids in school, throughout elementary school and into middle school, are concrete operational. And so it's very difficult. We should not be trying to teach them abstract concepts. Okay? The other thing that's interesting about this is that it turns out that many people never reach formal operational stage. We estimate only about 40 to 50% of people ever get to formal operations. So then, and we are not formal operational all the time when we get there. And that's one of the things that is a critique of Piaget's theory. So let's look at this. Neo-Piagetians have critiqued his theory and expanded it, and have noted, in fact, that only about half of adults ever reached formal operations, and that people are not in a single stage. A lot of this depends on expertise. So, looking back again at these stages, A person who is formal operational, perhaps in their profession, a lawyer or a doctor, if they're trying to learn something brand new, something they've never done before, they revert back to concrete operational, and that's what we all do when you're learning something new. Think about the last time you had to learn a new computer program. And I know I'm talking to some folks that are very experienced with computers. So this might not apply to you because you might be highly formal operational in computers. However, for most people anyway, when you have to learn a brand new program, I don't mean some little tweak on a program but I mean something you've never learned how to do before. You don't typically read through the manual. Even though you're formal operational, just reading all those rules and stuff doesn't really do it for you. You have to get on the computer and try it. You have to engage in Piaget's trial and error learning to see how it works. So when we're learning something new, we tend to go back to concrete operational. This is really important in teaching because when you teach people, they're typically not formal operational unless you're teaching a room full of people who are very expert, but rather they're more concrete operational. You need to give them concrete examples of what you're talking about. You need to provide pictures. You need to, if possible, let people try things and manipulate things and not just expect them to understand just because you told them. Okay? Another important critique of Piaget is that there seem to be very cultural differences among cultures in the kind of thought that is valued. Many people say that formal operational thought is valued primarily in Western European cultures, whereas other cultures don't even value that kind of thought, that kind of abstract symbolic thought that much. There are also, of course, situational differences. There are times when concrete operation serves you better. And the biggest critique, which will take us then to Vygotsky, is that at least originally in his theory, Piaget was far too individual. His picture of learning is the little individual child, a scientist, constantly trying to figure out his world by trial and error. There's not really much room in there for social interaction. And we do know, of course, that social interaction is absolutely vital to learning. So those are the critiques of Piaget. However, if you want to think about Piaget, what are some key Piagetian and neo-Piagetian, moving into some of those critiques, principles that apply to teaching and learning? Principle 1, people learn actively through trying to make sense of things, often by trial and error. In other words, don't expect people to just learn passively the way I am expecting you to learn from this screencast, but hopefully not just that. People learn mainly by assimilating new material into previous schemas or accommodating, changing their previous schemas to better fit the new material, which means that learning is built on prior knowledge. If the original schema is not there, it's very difficult to assimilate or accommodate. So prior knowledge matters. Principle 3, kids from 6 to 11 or 12 are primarily concrete operational thinkers, which means they often need to see or work with something concretely before they can manipulate, operate upon it in their heads. And, as the neo-Piagetians would remind us, even adults, Principle 4, who are formal operational, regress to earlier levels, primarily concrete operational, when they're working or learning in a field they're not very familiar with. So as a teacher, kind of expect that you're teaching mostly concrete operational people. Principle 5, when learners feel too great a sense of disequilibrium, they tend to shut down and reject the new learning. They stop learning. On the other hand, if you create no sense of disequilibrium, there's no reason for people to learn at all. So one of the gifts of teaching is maintaining that exactly useful sense of disequilibrium, where things are interesting and new, but not too weird, not too threatening, not too, oh my God, I don't know what's going on here at all.